Business Development Manager for the Building Products General Industrial Division for Sherwin-Williams. Maria has 36 years supporting the OEM industry through storm doors, fiberglass doors, and for the last 8 years in coatings. Maria. Oh, don't you just yell?
Howdy doody. Can I get a yeehaw?
Yeehaw.
Very nice. So I had the pleasure of seeing our next presenter in Florida back in February. And immediately I knew that this membership would benefit from this session. So I reached out to both Stefan and Terry, and here we are 3 months later with some good content in front of you. Phil Northcott is the CEO of Sea Change Labs, co-founder of buildingtransparency.org, and co-creator of EC3. He is a veteran leader of advanced R&D projects and leads a team of dedicated software engineers, bringing the best of information technology to the fight against climate change, with a core focus on carbon-intensive construction materials. Phil has extensive experience in computer-aided design, optimization, and manufacturing and quality. As CEO of Sea Change, he oversees the ongoing development of the free EC3 service, associated software services that automate the EPD process, and the development of custom EC3 instances for major multinationals. This presentation will give an overview of EC3 and the Revit plugin TallyCat, and then open a discussion about how the glazing and fenestration industry can declare impacts in an accurate, affordable, and timely way. So without further ado, please welcome Phil Northcott to the stage.
Thank you. That's a very fine intro. Oh man, it's like my own PR guys wrote that. Astounding. What are our chances of actually getting some slides up here? There we go. All right. Who needs slides anyway? All right. Well, thank you all for coming to this session. This is a labor of love for me and my team and for everybody at Building Transparency. We're a small group based out of Vancouver. There we go. We focus almost exclusively on climate change. We're pretty much climate warriors. We are the primary developers of the Embodied Carbon in Construction calculator, which is operated by Building Transparency, which I'll tell you a bit about in a second. A whole range of things that connect to it, including TallyCat, which is a Revit plugin, and we've developed an open standard for moving EPDs electronically between databases, program operators, manufacturers, called OpenEPD. And actually, the OpenEPD Forum is having its first official meeting next week. What we do is enterprise-grade SaaS. It's the fact that it's free is a bit strange, given that the level of enterprise security around it. And we work very hard with all of their various feedstocks that come into a database like this. The purpose is really, as a species, I suppose, but as an economy, we're going to have to do something like 100 times as much sustainability work as we have in the past. And we're not going to have 100 times as much money to do it with, right? We're going to have 2 or 3 times, maybe. That means we have to automate a lot. We have to be very efficient about this, and we need to build sustainability processes into the existing processes, especially things like inventory control and QA, where almost all the data already resides. That's the future. We're not going to be able to do documents by hand by expensive consultants and actually get to the point where we're going to need to be at scale. In terms of my team, we're mostly based in Canada and Ukraine. Some people are refugees from Ukraine, but otherwise that is the bulk of our team. We work really closely with Building Transparency. They're a 501c3 nonprofit out of Seattle. They were actually created around the EC3 tool. They are supported by the wonderful list of people you see on the left here. And the most important of that list, other than Breakthrough Energy Ventures, would be Amazon, Google, and Microsoft, who actually don't just sponsor the tool, They also enforce it worldwide. They have their own enterprise instances of the tool, and they demand EPDs of all of their suppliers, and they use this tool to calculate their entire portfolio, every building, every site. So why are we even talking about this? So I've had a few discussions here. Maybe people in this room, you know, don't believe that climate change is a thing. Trust me, honest to God, it's real. It's us. It's going to get a lot worse than it is now. There's a great deal that we can do about it. We're not doomed. All we need to do is put a business case behind doing the right thing. And that is what we're here to do our small contribution to do. As a kind of overall problem, about 11% of the problem is making materials that go into buildings. Another 30% or so is all the thermals and so on that you guys are very familiar with. It's the energy used to run the building, which of course is influenced by the stuff you make it out of. But over the next 20 years, we're going to be decarbonizing the grid. And that means that as the operational carbon piece shrinks, even if it's the same amount of energy, the amount of carbon associated with that energy is going to shrink. And if you imagine a hypothetical net zero energy future, the entire carbon impact of a building would be its embodied carbon. In fact, our goal is to keep up. Okay, that's completely achievable. We'll talk about how to do it and how to declare it. So, quite apart from just doing the right thing, because hopefully all of you who have kids in this room want to do the right thing because it's the right thing. There's also a whole set of regulatory limits coming down the pipe. You'll need to meet them. The other thing is that we need to get ahead of them, because if we don't set up robust systems with built based on really good data, government will use its very inaccurate sledgehammer and put bad regulations on. So if we can get ahead of the problem, we've proven now, I think, with our work with the General Services Administration in the US, that when we bring the right data to the table, they are much more accurate in how they place the regulations. I won't say perfectly accurate, but I'll say they're much better than they would have been. This is something we can do together, but Lord knows we, a little software company, can't do it ourselves, right? We need you. So, digitization. We've been digitizing every environmental product declaration we can find. Most of these are delivered in PDF format from some consultant. They're all in different formats. You can't do a worldwide database system where you can compare and contrast and track through supply chains if it's not digital. So we've been digitizing this in large quantities. We've got, actually it's now, but I think 147,000 EPDs from 67 countries, 60 different program operators. It's a lot of work. But this is where people come now to get EPDs, is EC3 and people who use, and a whole bunch of other tools that use EC3 as the core database. Who actually uses it? Well, architects are about a third of the number. Constructors, civil engineering, but the big builders, who are actually quite a small slice of this, because he who has the gold makes the rules, they are actually an enormously impactful group, although not large in number here. So we've mapped all of the plants that make glazing that we've been able to find that had EPDs. There's our current map. It's kind of scattered, you know. You guys know how many people are in this industry. The map should be a lot denser than that, don't you think? Right? We can do better than this. In fact, we took a look at Europe versus North America as a whole. And if you take a look at, you know, we're doing okay in terms of declaring the flat glass. But the trouble is there's not that much to choose, environmentally speaking, between one float glass process and another, other than how efficient you are in generating heat. The big differences come once you get into the assemblies, and in that area, there's almost no EPDs. Okay, we think we know why that is. It's a mass custom business. It's not a commodity the way, say, cement is, right? this is also a fixable problem. We'll talk about that in a minute. Just so you know where we fit very broadly, openings you can see at 420 EPDs is well down the stack. The reason the guys on the far left are able to have very large numbers of EPDs is automation. We spent, I don't know, 18 months now working with NAFS and the FGA and so on. This wonderful list of people and quite a few others who volunteered to help us build out the glazing category, actually describe it in a way that hopefully makes sense to you as industry professionals. If you go into each one of these, you'll see some of the properties we capture for each one. What we're attempting to do is that when you have EPDs for products, you can sort them down to a level where the comparisons are at least not ridiculous. I don't promise apples to apples. We can usually avoid apples to cucumbers. And again, the people who helped us with this are volunteers, and we very much appreciate them. Now, I'm just going to take a quick pause for terminology. GWP, global warming potential, that means how much warming over the next 100 years would you get by emitting X amount, like 1 kilogram of this material. The basic unit of that is the kilogram of CO2 equivalent. CO2, as you might know, has a lifetime in the atmosphere of on the order of 100 years. So it takes, its impact is very, very long-lived. Talk about LCA, life cycle assessment. Doesn't actually mean what you think it does in this context, but it really means is all the underlying data, some of which is going to be confidential, behind the sustainability analysis of the product. We are going to take that and we are going to distill it into an environmental product declaration that doesn't contain the proprietary details, but does have the certified results, so that you can pass to the next stage of the supply chain or to the builder. Another thing you'll see is something like A1 to A3 or cradle to gate. What that means is that from the time the raw materials come out of the ground, or of course, the recycled material enters the manufacturing stream to the gate of the manufacturing plant, that's the part that you guys need to help deal with. After that, transport to the site, yeah, you can't know that before you've made it. So that's the building's problem. And then what happens on site, again, that's the builder's problem. Those are A4 and A5. The part you guys need to really help with the data on is that A1 to A3 phase, cradle to gate. And with an EPD, what you end up with is something a little bit like a food label, like this. We were talking the other day about labeling programs. We very much go on the line of put a QR code on it and have an electronic record at the far end that does this. And if you take a look at EC3, you'll find a QR code that anyone can use for every single one of it that not only is short and easy to put in, it's got error correction coding built into it so that if you get it wrong, it will go nowhere rather than go to the wrong spot. One of the things you'll see me talking a lot about is global warming potential. A typical EPD tracks a lot of other things, right? Like excess nutrients into the Bow River over here, smog formation, acidification, that sort of thing. We're going to talk a lot about global warming potential. One, because that's the big regulatory push right now. And two, because it's the one that's going to kill us, not the one that's going to hurt us. Okay? And I don't want to poo-poo any of the others, but that's what we're going to spend most of our time talking about because that's the one that is the crisis just now. So let's talk about what you can do. So I'm going to pick on one bit, which is aluminum. So we all know what aluminum is for in glazing and fenestration. If you want to know what's different between one assembly and another in terms of embodied carbon, in terms of the carbon emitted in order to make it, aluminum is one of the biggest differentiators. How much aluminum? How much of it was recycled? And this is the big dog. When you make fresh aluminum, where did you get the electricity? Because aluminum is basically just two things. It's anodes and electricity. from a carbon perspective. And the difference between good and bad is 12 to 1, not plus or minus 20%, 12 to 1. Okay, this is it is not difficult if you pay attention to your supply chain and declare the actual emissions from your supply chain to get into the very best tier of manufacturers. Now, wood is more complicated. Vinyl isn't something I understand as well because it's not as carbon intensive as aluminum, and there isn't as much as you can do. I will say steel is another place where there's a lot you can do. But in general, look up your supply chain. That's often where the answer is. And what's the objective? Well, your customers have targets that they're going to have to meet. Let's get them under that target, and let's do it before it's a drop dead emergency for them. Okay, well, let me just check on my timing here. 20 minutes in, that's not too bad. Okay, so I want to talk to you a little bit about the language that we use. One of the really bad habits that you'll see if you are in the sustainability space or looking at EPDs is people will pretend there's one exact number. Like, processed glass emits this much CO2 per square meter. Well, no, that's not true. Everything in the real world has error bars on it. Everything in the real world has a range. So when we show these, what we'll show is there's a range from min to max, but the 20th percentile of the market, that is at least 20% of products are better than that. So what we call the achievable target. In a procurement, you should be able to do better than that. And if you as a manufacturer can get under that, you're going to be in our best-in-class category. If you really don't know what product you're going to use, it probably won't be worse than about the 80th percentile, which is to say 80% of all products are better than that. That's what we call the conservative estimate. And we don't suggest people use min and max for everything for anything, because nonsense tends to accumulate at the edges of any measurement like this. And nonsense doesn't benefit anybody. So that was a little bit long-winded way of saying, why do you want a database like this? Well, if you come in with like an industry PD, maybe what you know is, curtain walls emit 123 kilograms CO2e per square meter or whatever it may be. But that's plus or minus 50, 60%. Right? Actually, it's probably more than that on curtain wall because of so much aluminum. If all you get is a PDF of the EPD you finally selected, it's great. It tells you what you did, but it doesn't tell you what you could do, right? And it doesn't let your customers figure out what they could do. But what a digital search lets you do is it lets you say, what is an achievable target? And then what manufacturers in my area and can actually make a product that hits my specs that is best in class. And that's what we want. The other thing, frankly, we want is that if you are company B, your customer calls you and say, these guys are making X, why can't you? And the truth is, I'll bet you can. That's something we encourage people to do. Call your favorite suppliers and get them to make you something that hits that achievable target. So we're an open system. EC3 is sourced by lots of other tools. Lots of different program operators put their products into our EPD database, which we then exchange with all the others. This is an important thing to do because if we pass these things around digitally and they can be incorporated into LCA tools, they can be integrated into BIM tools like Revit, they can go into your own configurators. Open systems like this are very powerful things. That's why we use things like the internet. That's an open standard. So is the Wi-Fi we use. These are all open standards. It's really important to have open standards for stuff like this, and we are definitely driving that. So if you do want to go take a look at EC3, and I encourage each one of you to do this, go to buildingtransparency.org and sign up. It's a free service. You'll be able to see all kinds of demographics about the tool. And I'll just skip ahead a little bit since we've talked about these bits. You can search EPDs by category. Once you get in there, each one will have a form whereby you can actually refine the search based on product-specific characteristics. So, for example, under processed glass, we've got you can search by electrochromic or fire-rated glass, or um, there's a few others as well. Uh, yeah, tempered certainly, and two or three, I think, hurricane rated for IGUs. Do you need something hurricane rated, that sort of thing. So you can compare things that are reasonably good. You can also compare by geography, either in a radius around a project or by jurisdiction, as you prefer. And you're going to get a result, something like this, where it's going to show you for your particular spec what's the 80th percentile, what's the 20th percentile, how many results did you get, what baselines are there. There's also a whole bunch of regulatory filters in there. So if, for example, Cal Green or BioClean Colorado applied, and hopefully in the future some of the Canadian limits will be in there as well once they're actually released. And you'll be able to see what meets and what doesn't to the best of the ability of our guys to do the math. We've seen this before. This is a comparison of, you can compare by plant, by manufacturer, or even by geography. And it all goes into a big building plan, which is based on a cost model. It was actually based on Skanska's internal cost model. I don't know if you know Skanska, but they're a big general contractor based out of Sweden, but with operations all over the US. And we took where they started from and turned it into a very powerful SaaS tool. It's software as a service, meaning you don't buy the software, it's always running on the web. And you can, so it's a set of elements within a building, each with a category of material, a quantity, and a unit of that quantity. It speaks about 15 different kinds of units because we want people to be able to use their own language to describe things. And it's all based on taking searches of all of the available EPDs and saying this is the range for the kinds of, for the material you asked for, and here is the one you picked, if you picked one, where it sits. And then you can analyze where are the savings available in my building, and where is most of the impact in my building. Of course, those usually tend to go together. So the language you're seeing here is the height of the bar is the total amount of embodied carbon using the conservative estimate. The gap between that and the solid colored bar is the gap between conservative and achievable. That's how much you can do in procurement in order to fix things. And there's a line on it that says where you currently are at. So I'm just maybe I'll just quickly pause there for if anyone has questions about EC3 before we dig into Revit integration. Does anyone? Yes, sir.
This is a great tool. Thank you for sharing. But my only question is that over the next 15 to 20 years, the global energy production profile will change between renewable, nuclear, and other sources.
Right.
So how much of this will really stay as the carbon footprint?
Okay, so the question is, the grid is going to decarbonize over time. To what extent will these numbers be accurate? And the answer is, these numbers are going to change every year. That is why we want to automate and process this. The embodied carbon that we have here is not exactly the same. Like, it doesn't scale with your local grid. It scales with the chemical processes at the plants that produce the materials and with the grid at the source. And that means that even if we decarbonize perfectly, let's say in British Columbia, if we're importing, let's say from China, it's the Chinese grid that matters for the aluminum. And that's why we have to enforce kind of our values through what we purchase. Even though the power, like their grid is not under our control. Only what we purchase is under our control. The second thing is EC3 really, really tries not to make predictions 50 years in the future. I mean, we do have grid decarbonization graphs and so on in the system, but we really try not to do that. We try to focus on what can we do now in order to change the answer, if that makes some sense.
So there's a lot of front-loading work that goes here. Like as you go through the EPD process, there's a lot that you're going to build up in the background that's going to have to feed this data.
Recording
So
in
like the
progress.
ISO 21930 is going to give you kind of a breakdown between, you know, production stage, construction stage, use stage, end of life, and resource recovery. There's a lot of variables that kind of come into play after you've gone through that certification. But to Phil's point, once you've gone through this, there is going to be a requirement for us to continue to feed that information. Like really, the first thing we saw coming out of the EPD was here's a bunch of low-hanging fruit that is obvious we are not doing as good of a job as we could. And so once we've repaired that, my hope would be to go back through, get a better number next year, and try this again.
Well said. I'll just add to that. The tradition has been to do an EPD every 5 years. I think during this transitional period, that's not going to be fast enough. Really, what we want to do is have a system whereby once we have it set up, EPD just comes out every year, right? And so the faster that you get better, the faster you look better, and the tighter the link between doing the right thing and getting a better business result, which is the link we have to have for this to work.
Phil, I don't know if you hit this, but I may have blacked out. Yeah, it happens. So where are the EPDs coming in from? Like this is stuff that people have filed with you, or you're scouring around in databases around the world to find these things? Like it's sort of
We are we are scouring all of the program operators' sites for these EPDs. The ones who have a little bit more foresight are pushing them directly to us.
right.
So the most modern of the operators, like Smart EPD, WAP, Climate Earth, are pushing to us over OpenEPD.
Okay, so that's kind of where I was going on. That was like the interest in this room is on two sides, right? There's the procurement side for getting the materials, but there's also the interest in probably having their own EPDs listed up there, right? So you were probably coming to this, but I imagine the call to action here is to get everybody to send in their EPDs as they make them.
That's exactly right. So actually, I'm going to use this as a segue. Okay, who here, by a show of hands, who actually has an EPD for their product? All right. Okay. Well, you don't count. So I gotta count 3. Okay. So next, who's working on it? There, 2. That's good. Who thinks they're gonna need one in the next 5 years? Okay. There we go. Much better. Okay. So now my question. I'm gonna pick on you. What are the barriers that you guys see? How many people see the biggest barrier as lack of demand? I got nothing. Okay. How many people see the biggest barrier as cost? 1, 2, 3. I'm surprised it's that low. Okay. Data is data. Okay. Third question would be, how many people see the barrier as it's too much work? hard to get data from suppliers. There are many gray areas in the PCRs. I very much agree with you. Anyway, thank you. And now I'm going to go back to question.
Actually, this I can turn it into a fourth question. How many of you see this as a value add to your product?
How many people see this as a value add to the product? By show of hands?
And the reason why I bring this up is you mentioned food labeling. And this
Yes.
is my actual original question. Food labeling to me is all there for behavior. It's
Yes.
there to influence behavior. And I know how many calories I burn when I run on a treadmill.
Yes.
I know how many calories I consume when I eat a cheeseburger.
Yes.
And I do the math and I go, oops, this is not good. And I make a behavioral change in my life that's healthy. I see this as a tool to impact behavior.
Totally, absolutely correct.
Here's the problem. The people that have developed the labeling put it in the language that no one understands. So what is a kilogram of CO2?
What's a
How do I cut that in half in my life? How do I sit at a kitchen table with a homeowner selling windows and say, if you buy my windows and you care about climate change, my windows are going to cut your CO2 behavior in half. And the next person comes in and the homeowner goes, so how much CO2 am I going to save? And the person goes, I don't know what you're talking about, but I don't even know what a kilogram of CO2 looks like because it's invisible. And honestly, I criticize climate activists are speaking in a language that society has no clue what to do with it. And hence, why are people so opposed to climate change perspectives? It's because they can't talk about it. In our industry, we use solar heat gain coefficient to define heat gain on a window. What is a 0.5 solar heat gain? How does that feel to you? Can you answer that question?
No.
But if I told you this window is going to let in 1,500 watts of energy on a hot summer day into a bedroom, do you know how hot that's going to be?
Pretty
That's-
close, yeah.
That's like a baseboard heater turned on all summer
That's,
long.
so
So
toasters.
we have to frame this, and when I say value, you have to frame this concept so manufacturers see value in doing this. And the only way they'll see value in doing it is if they can pitch it to a customer.
So, amen, brother. My only excuse is I'm an engineer.
Oh, that's the problem.
Yeah, one of many, believe me. Okay, shall we keep moving? Oh, one more, sir.
Yeah. So I'm going to sound like a broken record here.
Oh, come on.
We have no float glass production facilities in Canada. And the reason is environmental activism. Anytime somebody proposes a float glass plant to go anywhere in Canada, the environmentalists say, no, that takes too much energy and it emits too much carbon, and that goes on our scorecard for a country in the negative column. Therefore, we can't do this in Canada. And even in places, you could put one in the province that has the absolute best, cleanest grid with hydro, and it'll still be opposed. It'll never get off the ground. Instead, we buy it, in some cases, from countries like China. We ship train loads of coal through the port of Vancouver to China. We've increased our shipping capacity of the port of Vancouver in the past 5 years by an amount that the CO2 equivalent is more than the entire province, all sectors, emits. And then we buy glass back that was made by burning that carbon. What is going to happen to change that?
All I know is I will do what I can. That's it. You're not wrong, but you have to do what we can actually do. The one thing we can do, I will say this, is that if they burn the coal to make the power, that has to go in the EPD. If they don't declare it properly, we take that conservative estimate as the assumption, which is not friendly, right? We charge them their carbon price at the border on the way in. By the way, we should be rebating the carbon tax on the way out too, so we can set it nice and high without damaging our own economy. That is the best we can do. And yeah, you know what? The coal needs to stay on the ground. We shouldn't be shipping it, but I'm not in charge. Okay. Back to slightly brassier tax for a second here. Let me just do a time check if you don't mind too much. We're doing that 38, okay. So Tallycat. So Tallycat, the name is based on a tool by Kieran Timberlake called Tally, which is now called Tally LCA. So this is the Tally Carbon Action Tool. It's an integration with Revit. We work very closely with Autodesk. There was a sponsorship from the government of British Columbia through Energy, Mines, and Resources that helped develop this, also with architects Perkins and Will. What it lets you do is take a design in Revit, export all the material quantities. You tell EC3 what they are in some detail. It will do all of the usual lovely EC3 things to evaluate the climate impact. You can do visualizations both in 3D and in the nice Sankey diagrams and bar charts and pie charts. And then it takes all of that stuff that you've annotated for your building and it puts it back into the Revit objects. So the next time you use the Revit objects, the user doesn't have to go through all of the extra math. And this is going to come to something really cool in a second for you guys, because you can also do this without a building. You can just put all your products into Revit, load them to EC3, annotate them, send them back, and now you've got RFA files, RVT files you can send your customer that are full of all of their sustainability data. When they just pick that up and put it in a building, they've got all the sustainability data already there. They don't have to enter it. It's a pretty cool technique. If any of you guys are interested in doing it, we also got a really nice little management tool, and we can help you guys get your libraries of stuff all beautifully annotated for the architects to use. Basic method is stuff is in Revit, the geometry comes into EC3, and then once EC3 describes to Revit what is this stuff, because Revit doesn't understand materials really, that data gets annotated back in. You can write it into the libraries. These are just RVT, RFA files. There's nothing special here. It's an open standard, which then somebody else can use. There's quite a few people using these across offices of architects or structural engineers. This is the point at which I would do a live demo, which I'm not going to do because I don't want to risk the Wi-Fi here. But this is the kind of thing that the library browser looks like. It's got lists of, for example, walls, curtain walls, windows, and so on. It's got the emissions of them, and then a selection of specific properties that are different for each category of material that you can annotate, and they have to be annotated by hand because Revit doesn't understand this stuff. But once you annotate them once, you don't need to do it again. You can publish these libraries, and we can help you publish them on the web if you would like us to. And by the way, there's no reason you can't put cost data in there as well if you wanted to. You don't have to. So one of the questions I was asked at Autodesk University that I had to think about a bunch was, what is the standard of care for architects and designers? What should that be for sustainability? Because they don't control how things are manufactured. They don't even control what actually ends up in the building. But what they can do is design it so it could be built sustainably. It could be procured sustainably. And then the architect's job is mostly done. Provide that as a target. When you actually procure this and install it, you need to get under that GWP target, which we've proved is achievable. And then once it's actually built, you have to close the accountability loop and actually find out what happened and report that to the owner. That's going to be the key to making sure that all the good sustainability work that gets done doesn't just get value engineered out of existence at procurement time. Okay, that loop has to close. And that's what those labels were about yesterday too, right? Is the accountability at the end of the day. So where are we going? So you've seen this slide. We have almost nothing in North America for framing, windows, and the higher levels of assemblies like that, and very little for IGUs. We think, but people make a gazillion different kinds of windows in a gazillion different shapes. And the way EPDs work, you're not supposed to put an EPD for something that isn't plus or minus about 10% to the truth. But if you took a look at a typical window, and this was Tom Bauer did this for us across their actual portfolio. They said, well, if you take a look at the width and the height, how big is the spot that their EPD actually genuinely covers? And it's just a little stripe in the middle. And this reflects the fact that this is a mass custom business. And when people did the original EPD processes, they were thinking commodities, not mass custom. Okay? So what we're proposing to do, and this is dependent on, well, we're attempting to launch this now, is we propose to do an LCA for the complete plant, get that verified, and then connect up that analysis, your bill of materials, and then every time you produce a product, we can immediately spit out the right answer automatically and just have it direct deposited. We think this is the right first step, and there's actually a step beyond this, which requires a bit of a change to the PCR, but to make it even better than that. This, we think, should cut the cost of doing EPDs down to something reasonable, and we can do it every year. So you just run it every year. You don't have to spend a whole lot of money. You just have to update your fuel and electricity numbers. We'll get the updated grid numbers, and just reissue them all every year. And it's just computers doing most of the work. So if this is something you're interested in, please come talk to us. If you do ship to the United States, there's some grant money to help with this. If not, hopefully we can make it pencil anyway. This is what we think is going to be necessary to get across the board. The flip side is, if we don't have declarations, there's nothing differentiating you doing the right thing from the guy who wins the value engineering game. I also think we can do this for curtain walls, where we can actually ship an assembly, not one EPD for the curtain wall, but here's a package. Okay, it's got its EPDs in it, it's got its quantities in it, it's ready to be deposited into either EC3 or into Revit. We've also figured this out after talking to a bunch of our enterprise customers who do a lot of this stuff. So if curtain walls are what you do, we think we've got a solution for this. So I'm going to pause there. I'd like to hear from you guys whether you think this is the right answer, whether this is something you want to do, and what you think we can do to make, spray WD-40 on the bits of this EPD system that are stuck.
Thank you very much. I just want to go and say this. For me, it's a complicated subject. Maybe I see a lot of engineers in the room, but I'll probably not be the person responsible of this project at the office when I come back. But that being said, one of the questions we get most asked about, and I want to understand how this can help us by our architects, is when they're doing a big project, they often say, okay, what type of products should I be choosing? Because, for example, if I go with a triple glazing option, probably I'll consume less energy, but we're consuming extra component that's actually like, we have a world storage shortage. I wrote it down. Sorry, shortage problem with the glazing. So they're asking, what should I put in? Is it really better to consume more? But what am I going to save? And depending where the project is, like if it's hydroelectric electricity versus other types of heating. So there's a lot of questions that were being asked, and they're asking us, how can I choose the better option for my project on the product and life
Yeah.
cycles and
It's the right question. I wish I had a quick answer for you because it really does depend on, um, what else is in the envelope, how is the building used, where is the building, what can you reasonably project about decarbonizing the grid over the next 50 years. It so hugely depends. Um, so there's no glib answer for you. The only thing we can do is our database connects directly to a bunch of different thermal analysis tools. And so if you have the answers, if you have stuff in EC3 and you can go to something like Cove Tool or, any tool that interacts with EC3, and you can put those two pieces, your thermal analysis, your power analysis, and your embodied analysis together. That's the power of open systems, is that you can connect best-in-class tools to each other. I wish I had a simpler answer than that, but unfortunately, the reality is that's complicated.
What's going to prevent fraudulent environmental product declarations?
Very good question. Okay, so the short answer is accountability. So and normally I would just pull up EC3 and show you, but I can't do that right now. So the basic thing is every time there's an EPD in EC3, right, which is just a reference, that because it's a public record, it's disclosed to the verifier. So the verifier has a list of everything they are alleged to have verified. The program operator has a list of everything they are alleged to have published. And so somebody can give you a piece of paper, but they can't just change what's in EC3, right? What's at the other end of that record is not under a fraudster's control. It's tracked from the source. So I can't stop anybody from giving you a piece of paper with anything on it, right? I can't, for that matter, I can't prevent you looking at a video that shows that the rebels blew up the Death Star, right? But they did, but it was a long time ago, and it was in a galaxy far, far away. So it's actually very hard to falsify a public record that's in the public space when the author can see it. Does that make sense? So that is the base technique that's now used, for example, for passports. The only thing these days they look at on a passport is the number. Okay, they look at the number, they look up the record, and they look at you. They don't care what else is on the passport. They only read the number. And that's the basic technique we're using.
Oh, are you? Okay. Oh, that's why. I feel like I've encountered some disturbing conspiracy theory about the Death Star being an inside job. I don't yeah, false flag. I don't like that. That's a little scary. I don't on the comment with telling the architects, right? I mean, the operational energy is in their wheelhouse, right? I mean, I think all you can do is use this system to give them your data.
That's correct.
And then they have to figure out what the energy savings is going to be and whether it all balances out.
Or more precisely, a good quality thermal tool that understands
Right.
grid decarbonization. But yes.
Yeah, right. And they're never gonna get a future. Like they're not gonna have accurate 50 years out stuff.
No,
right?
absolutely not. I've actually got if you'll let me soapbox for a moment.
Yeah.
Who here knows the term net present value? Nuts. Okay, this can be harder than I thought. So net present value, if you get a bond where somebody's going to pay you $100 in 10 years, it's worth a lot less than if somebody gives you $100.
Right.
Okay. The discount where it says, okay, what today is $100 in 10 years worth, that process is called discounting, and the current value that $100 in 10 years is worth is called its net present value. Okay. You can do the same thing with carbon. Future carbon, if you could just delay emitting, that's a good thing. If you could bury today, hold it for 50 years and release, that would be a valuable thing in and of itself. One of the great tricks, so our next gen analysis stuff has to take time value of carbon into effect. That also means that the inaccuracy of our far future projections stops looming so large over our analysis.
It can be sort of mathed out. In other
It-
words. Yeah.
Yeah.
Just yeah.
Because ultimately we have to act on what we can be pretty sure about, not on wild guesses.
Yeah. I got a bunch here. I'm gonna have him on the podcast to ask all my questions. The low carbon aluminum availability. They've electrified, I think, 1 or 2 smelters in Europe. I don't think there's a whole lot more than that. Are there?
Almost all of Canada's smelters are fully electrified.
Oh, are they in the
Yeah.
ones? Okay, that's
Yeah.
good.
In general, just so you know, in Canada, what's happened was the aluminum smelters built the dams, not the other way around.
Yeah. Okay. So that's good. The one thing I think everybody here will probably find an attractive message is, how does durability play into your equations here? Right? So, and I know that's another one where it's like, well, you have to do a lot of math to figure it out, but that putting up a building and putting up facades and putting together the assemblies that last twice as long, right? I mean, that's, I think, whatever the work here that everybody here would like to do. And so how is this a tool that can be used to promote your ability to do that?
Man, I wish I could say yes. Okay, so here's the problem. Durability absolutely matters, right? If you have to replace something every 10 years, you know, its net present carbon is huge compared to something you have to replace every 40 years. The brutal headache we've got is there's no standard way where people agree that this is 35 and that one's 45. So that is my migraine, like, in answer to your question. I dearly wish I had better answer than I do, because what I've actually got is Jack. So what I'm going to do is ask a question to you in return, which is, how did Darth Vader know what Luke Skywalker was getting for Christmas?
I don't know. How did Darth Vader know what Luke Skywalker was getting for Christmas?
He had felt his presence.
Oh no! Oh, we must be on a time.
Does a triple glazed unit have 100% more chance of failure than a dual?
Oh, no, it's 50% more.
Is it?
No, it isn't. Of course it isn't. I'm just.
On the durability issue, we're starting a new committee in Quebec called Matériaux Infinis, where we're going to look in each component and try to define time, duration, information on paint, finishes, materials. And we want to use that to feed the market, because we know the federal government is asking us about recycling cycles and everything. So we're already starting in a couple of weeks our first meeting. And it's going to be a hybrid meeting where there's going to be people from commercial as well as residential, where we're going to talk about all the types of products in the market and try to, so maybe it's something we could share eventually.
What I suggest with that is, if you do that work, please bring the output of that work to the product category rule for glazing, because that's how it gets propagated. And by the way, question to you, when somebody goes for an audition, why do we tell them to break a leg? You know, it's so they end up in a cast.
Because this is more of a curious and a request and maybe a consideration, that can nuclear footprint be added to this data? like how much nuclear energy is getting used. I know we are looking at carbon right now, but this is again one of my thoughts that over the long run, nuclear will become an even bigger headache. But if we are targeting other than non-renewable and non-hydro um, uh, energy sources, then should that be or possibly be considered to be added to this tracking system?
Okay. So can we effectively track how much nuclear waste, how much radioactive waste was generated by, due to power in the process of making something? The answer is the systems do in fact do that. We don't focus on it because again, we're aimed at the crisis, not the long burning problem. So the system is set up to do that. We don't, it's in the list of the 20 additional things that people track. And the one thing I would say is if we get lost in those 20 things and fail to deal with climate change, nothing else is going to matter.
I'll make this quick. So yeah, I, there are two major issues that we found kind of going through this process. I know we've already.
Speak more directly into the mic.
Yep, sorry. All right, so there's two major issues that we ran into going through this process, but I'm curious, given the spectrum of products that you guys have gotten to see on this field, are there specific issues you'd like addressed in the procedure or process of the LCA EPD implementations?
Are there specific recommendations we would make in terms of the process as a whole?
Yes. So we have the frustrations we ran into going through it, but are there specific things you'd like to see? As an example, we talked about the 4 different ISOs for LCA.
Yeah. Okay. So there are about 4 things that we want to do. The first is we want to bring in, we would like to see publicly funded product category rules so that they can be produced and ones that are updated every year so that we can be much more active in managing the rules, to reduce silly overhead and improve accuracy. The second thing I would say, we've talked a little about automation. There's a specific thing I think we need to do, which is have environmental product declarations that understand more than one parameter. It's a bit, in the weeds, but for glazing in particular, or for windows and doors, square meters won't do. It's got to be square area plus perimeter. And with those 2 things, we can cover vastly more of the real product space with a lot fewer actual pieces of paper. That's, I guess, 2. 3 is we have to come to an agreement that we're going to ignore the stuff that doesn't matter. Because there is, like, if you try to track all the bits, it's vastly too much effort. We have to agree that, these bits we can just treat with a broad brush. We'll just use a conservative estimate for all these little bits and, focus on the 80, not the 20. Right? So that would be, I guess, the third. And the fourth thing is ultimate broken record, automate, and then automate some more. Bring it right into your normal business processes around inventory control and quality. I think that puts me at time. Any last bits for the good of the order?
On the automation piece, so that looked like, you were talking about your tool that can spit out basically the EPD based off you put all your background information in there, you change it for the specific product, and then it comes out. And you were talking about updating, yearly or something like that, your EPD.
That's right.
Why couldn't you do that with every estimate? Why couldn't you do that with every quote? It's automated. You're producing a custom EPD for each size, or you could.
Right. So your question is, could you just do it on a per quote basis? The answer is absolutely.
Right.
But remember that the architects, when they're doing it, need guidelines that are close to the truth. right? So there is a
Well, aren't you closer if you're putting in the actual sizes they're specified?
that's correct. But well, in short, the answer is yes. Batch specific EPDs are a thing. And they even in EC3 they get a credit for being even more accurate than product specific EPDs. So the answer is absolutely you can do that.
Yeah, just integrate it into your quoting software and
Yep, without a doubt.
you
You
get to work on that.
absolutely you can do that.
I think I heard somebody say site specific U values somewhere in there. Last one.
So how does this affect the housing crisis and affordability?
How does this affect the housing crisis and affordability? Well, let's put it this way. We're going to have to find ways of building housing, in an affordable way. Certainly where I live, the problem isn't building it, it's the land. So the really short answer is I don't know. All we can do is we have to track this stuff. Since we have to, let's do it as efficiently as possible, to an acceptable level of accuracy, right? So not so precise that it takes a year and a half and it costs a fortune, but not so sloppy that it's easy for somebody who's actually doing bad stuff to slip through the truck-sized cracks. So that's my best answer.
Bill, thank you very much. Huge topic. If you're not thinking about it yesterday, you need to be thinking about it moving forward. A couple of quick things. Thank you so much. Appreciate it. First off, our sponsors, I'm not going to read them this time, but please support our sponsors. Check out the exhibitors. And one other thing, Ted Petkow with Window and Door Components. He is raffling off a pizza oven, and I've seen their pizza oven. How window and door components and pizza ovens go together, I don't know. But so drop a business card at his booth, and we're going to draw at 12:30 for a really nice pizza oven. Enjoy lunch. We'll be back here just after 1 o'clock.